and welcome to the new normal for database DevOps, how dynamic infrastructure solves the hardest problems in continuous integration and continuous deployment for databases. My name is Kendra Little, and I am very excited to be joining you at SQL Bits for this talk. I'm a DevOps advocate at Redgate, and what that means is that I get to spend time thinking about how to solve the hardest problems when it comes to database code development and testing and deployment. This is really, really interesting because I get to work with real-world customers as well as with developers who are working on this in our product teams and product designers and program managers to figure out what are the best ways to make this easier, to reduce manual work, and to make code quality better. Like, how do we actually just make this all much, much smoother? So that's what we're talking about today. We're talking about what the state is of how people are doing this, how things are really changing and already have changed in the world of database development and deployment, and then also where they are going. So we're going to talk about a few things today. First, we're going to talk about what is difficult about this, right? Why isn't this easy? Then we'll talk about what this new normal is. This is really how things have changed dramatically in the last few years. What is expected now that we didn't used to expect, and where this is moving towards. Then we will get into some more details around branch alignment. We'll get into a demo. There won't just be slides here today. And then we'll kind of pull it all together and talk about the future and moving forward after that. So first up, what is so hard about database DevOps? Why is this still evolving? Why weren't all of these problems either solved a long time ago, or in addition, why haven't all the changes, why haven't all the improvements that people have made in terms of developing and delivering application code, why haven't those just been inherited by the database? Well, going back, databases aren't naturally treated as code. And this is true for a variety of different database types, both SQL databases and NoSQL. When you look at databases, there's different perspectives on them, and there's two really extreme views on this. At one extreme, you have folks who sort of think about the database as just sort of a cardboard box that you put stuff in. And this might sound like kind of a caricature, but there was an interview I was in once where the person interviewing me held this view and was like, so yeah, the database is really just a storage receptacle. It's just a persistence layer. It doesn't really matter. It doesn't really have any intelligence. Now, this is a really extreme point of view. There's gradations of this, right? At the other end of the spectrum are people who think the database is a highly optimized application running code and persisting data, and it is so highly optimized that all of your business logic should be in the database. All of it. All of it. Right? So that's an extreme as well. Most people are somewhere in the middle. Right? Most people may be closer to one end of the spectrum as others, but the fact that there's such disagreement on what the purpose of the database is really kind of led to it not being treated as something where you would even put the code in version control, because is it real code? Now, I would say, if we think about this, even if you're really pretty far on that end of the database is a persistence layer, the database schema is still a really important thing. And only storing that schema in the database, where there may be a whole lot of data and restoring backups may be really inconvenient and take a long time, that still doesn't make sense. But I think this perception of the database as not really code is why, for a long time, very few people even had code in source control. Another factor that has really slowed the maturation, the maturity of the database development and delivery lifecycle is that there's very strong, long-standing silos between database administrators and developers. Now, these silos aren't just the DBAs and the developers. There's also silos between network people and everyone else and security people and everyone else, right? Like these silos are pretty long-standing, but what they've meant is that as improvements in technology have come across, they tend to be adopted in isolation by different groups. Developers have adopted Agile and DevOps methodologies, and those have largely been applied very successfully to application technology because the management of that's much closer to developers. Whereas DBAs tend to be in silos that are closer to things like storage administrators and other folks in this more structural IT area. So things like, hey, we've got really cool new SAN technology. Often the new features with that don't all get enjoyed by the developers. But maybe the DBAs get more of them because they sit near, this is now none of us sit near to anyone, but sort of metaphorically sit near to the storage administrators. And even when we are all friends, right? I don't mean by this image that we're at war. It's kind of a game, but because traditionally these silos have different ways that they're measured for success, it does end up getting a little competitive. And by this, I mean, traditionally, database administrators are rewarded for the stability of the production system. And traditionally, developers are rewarded for their ability to deliver change quickly. Now, often, how do you keep a production system stable? Well, maybe you resist change to it, right? So this leads to something called the wall of confusion, where developers are measured by this outcome of being able to deliver new features. But every time they try to do this, they're throwing something over this wall between the two groups. And the DBAs are like, my measure of success isn't whether you can deliver that feature. My measure of success is making this system not ever have performance problems, and change is scary. So I'm going to throw this back. I'm going to find any reason I can to throw this back. Part of what we're seeing now is a real movement to have shared goals across the entire business so that everyone is responsible for stability and everyone is responsible for delivering feature. And that breaks down this wall of confusion, or in this photo, it tears down the volleyball net. But historically, it is a reason why this has been very slow to progress. And the third reason that this has been slow to progress is just different approaches to how you get a database into version control. So like I said, part of this was we aren't even treating the database as code. And then we've got these differences, right? So people aren't sure how to treat the database as code, and we don't have the greatest communication, to put it mildly, between the developers and the DBAs. So this has led to multiple approaches to how, if we're going to put the database in version control, how do we even do it? So there's two very popular approaches. This is spread across different database platforms. Some people like an approach that captures the schema of a database and it stores the schema in source control. So this is always storing the whole create table statement, the whole definition of every object in the database. And then with this model where you're storing the state of the database, with this model at deployment time, a comparison is done by tooling and it automatically figures out, like Google Maps or Apple Maps or Waze. It says, oh, how do I take you from where you are to this destination in the most efficient way? And it auto-generates the code to get you there. So some people are in that camp. A lot of people in the Microsoft data platform, that approach is very popular because there's been a variety of tooling from different vendors, including Redgate and Microsoft, as well as other vendors, that has taken that approach and it's caught on. This approach also exists for other platforms as well. You'll see some tooling for other database platforms that does this, but in other database platforms, like if you're looking at a Postgres or if you're looking at an Oracle or a MySQL, you'll find that very, very popular is a different approach, an approach in which what you check into source control is not always the full definition of the objects, but for it, what you do is you craft the scripts that actually make the change instead of having a computer automatically figure out what is the most efficient way to get to the destination. The developer has control. What are the exact steps I want this change to be done in? And this can be great. I mean, it might sound like more work. There's things that can make it easier, but right, it might sound like more work. But if you think about some changes, there's some changes where you really want to decide how it's done, especially if you're involving moving data around in a database. If you've got an existing database and you want to take something that's in a column in one table and you want to move it to another table and you don't want to lose any data, and maybe it's a big database and you don't want to cause any blocking, maybe you do want to figure out what the right steps are for that, right? So these two different approaches, it's confusing. There's which path do I take? Which path do I take? Well, part of the innovation that we've done at Redgate is to not make you have to choose, to have an approach that combines both of these features so that it isn't necessarily one or the other. It is a combined approach that has both. So what I want to talk about now is start talking about not those problems that we're going to get past the baggage, the problems of the past, and talk about the new normal now. Part of the new normal now is wanting to be able to get early response or early feedback, rather, in the development cycle. And what this means is when you are working in the development cycle for databases, just like for application code, you want to always be really clear on what is the state of production, and ideally, what is the data in production? Right? If new columns have recently been added to production and data has started to populate those columns, having that data in your development environments is really, really useful because maybe you had an idea of what that data might look like, but maybe it's different than what you imagined. So the pattern that we are following now at Redgate, and this is the pattern that I think we're going to see in tooling and in database processes everywhere, is that we want to be able to, in the software development lifecycle, have a lightweight representation of that production environment and to be able to regularly update it and to base our development work on it. Now, this is really powerful because it bridges that gap between production and development. Now, we do have to think about data security and privacy, right? So we not only need a way to have a lightweight copy of production, but we need to be able to mask sensitive data in there as well. This idea and this concept is finally coming to fruition, right? This is something that even 20 years ago, like thinking about SAN technology, this is something that I've wanted since the days where I worked at a little software company where we rolled our own tooling. But it's taken us a really long time to get here, a lot of which is due to those silos. But now is the time when this is really happening. And if you look at the movement with containers and Kubernetes and different stories around there, all of those stories are leading to a future like this, where containers don't just revolutionize our production environments. Yes, they are revolutionizing our production environments, but first, containers and similar data virtualization technologies are really revolutionizing the development and test environment. So here is the way that we are working this out in Redgate products. We have the ability now to say we have this representation of the production database, which is refreshable in the development environment. And when you build changes on top of that, this is done by creating those individual migration scripts, and you're able to apply those to that clone of production. And on demand in development, you're able to simulate a production deployment even as you're working in a sandbox-like environment. What this looks like, another view of what this looks like, this is the same thing, but just showing what this looks like with scripts, is that you're able to put into place as if you're doing a database restore, but without actually having to restore a full database, using the powers of basically storage technology, right? Say, hey, we're going to pop a snapshot of this database, or we call it a clone, into place. Now, the way SQL Server works, in this case, this example is a SQL Server example. The similar thing can be done with Oracle. You just need the storage technology to do this. But when we put that into place, just like with restoring a database, when you restore a SQL Server database, no validation happens to that code, right? I mean, SQL Server it has to not be corrupt, but it can just pop it into place. It doesn't have to check like all the views, like, hey, are all the tables that view refers to, do they all exist, right? Because SQL Server, when you're creating a view, for example, if you try to create a view with a script and it points to a table that doesn't exist, it's going to say, that is invalid code. But if you run a sequence of commands where you create two tables, and then after that, you create the view. So, right, the view, it worked when it was created, but then you drop those tables. You can absolutely do that if you didn't create the view with schema binding. SQL Server lets you do that, but now you've got a view in your database that is invalid code, right? So what we do, this is part of the magic of, instead of basing all our validation on scripts, we don't want to base all our code validation on scripts for databases, because reality is messy and our existing databases may be messy. We don't want to introduce more mess into them, right? But we need to be able to start even in the middle of a mess. We want to be able to pop a representation of that database into place. And then on top of that, be able to run, validate, and develop scripts on top of that. But we need to get early feedback too. So we want to be able to regularly update that representation of production. And this is why the clever use of basically a kind of database container as part of the development environment is so powerful. And this is why I very much believe that in 5 years' time, this is going to be incredibly common in all development environments to be harnessing technology like this and using it for database development, because this model really does change the game. It allows us to, when I say left-shifted production deployments, it means we can simulate production-like deployments, even, in the early stages of saying, I have this crazy idea. What if I do this? It also means that different teams across a large organization that may be doing quite different things. Maybe one team is working on a new microservices project while another team is working on a legacy database. All of them can start right away, no matter the quality of the code in the different environments, no matter the complexity of the code. It also means that our builds are going to be faster. So when you think about building database code, do we want to be building, verifying, and packaging all of the code in all of our databases all of the time? I mean, it's a nice idea. But when it comes to the reality of a lot of databases, a lot of these have very large amounts of objects in them and a lot of complex relationships between them, a lot of dependencies between them. When it comes to being able to very quickly validate the changes that matter most to us are the changes that have not gone to production yet. Those are the changes we really want to be able to build, validate, and package. And that's going to be a much smaller set of changes generally. I mean, even if we only deploy every few months, that's going to be often for these complex databases, a much smaller set of code than all of the code in the whole database. So using this baseline or representation of production as the basis for our deployments speeds up our builds. We're seeing this being adopted by some groups very, very quickly. In terms of the last year, couple years, who is really doing this? So if you look at this list of where does this matter the most, right? What industry is it where code quality is really, really important? Or industries, really, there's more than one. which of these industries have been developing in databases for a long time? So they've got a lot of complex databases and they've got a lot of teams, right? They're not, these industries have organizations that can be quite large in them and they need to deploy frequently and they may have had a lot of complex business logic, right? So who fits this description? What we see, both in working with customers as well as in our survey data, our State of Database DevOps report, financial services they are among the most frequent releasers in our survey. There is significant competition between folks in financial services to be able to innovate and to be able to do it safely. You do not want to mess up financial data, right? So you need to move fast, but you also need to do it in a way that allows you to really promote code quality and ensure code quality. Healthcare is similar to this. With healthcare and financial services both, the ability to do this safely and to mask data in this representation really, really key. But we've got these industry pressures and the need to move fast. And the IT tech folks are certainly not being left behind. So these are the three biggest groups where I see there are really organizational level mandates that we need to be able to do this better. But of course, we do also see this in other industries as well. So there's other things to take into account when thinking about why having virtualized data, why bringing a representation of the production database into play helps make sense. And part of the second part of this, right? So we've talked about why it makes sense from a building and validating your code sense. The second bit of this has to do with how we manage development environments. Whether you're a DBA or whether you're a developer, how do you, from that sandbox period, how do you conceptualize your database code? How do you test it? But then also, how do we validate it in builds? How do we validate it in QA environments? How do we ensure that quality in code? And branches are a big part of this. Branches in Git, we see that Git overwhelmingly has won the version control awards. There's still others that are out there, but most people use Git these days. Git really encourages branching workflows, right? So not every version control system ever encouraged branching, but Git really does. Like, it is frustrating and more difficult to use Git if you do not use in a branch-based workflow. You can easily, if you have many people who are writing to the same branch, it is very easy to end up in a situation where it gets like you try to pull and it's like no, and you try to push and it's like no. It wants you to be working in separate branches so you can isolate your work, but also be able to share it by merging in code from other branches or merging your code into other branches rather than having put all the code in the same branch, but locally and remote, and then trying to merge while pushing and pulling. Git wants you to work in a private branch. Well, if I'm working in a shared database, like let's say I'm trying to design a new feature and my colleague Grant is also working on a new feature, and maybe we've got a big giant stored procedure with a lot of business logic in it, and we're both working on the same stored procedure, and we're both trying to work in the same database, but we've got different branches in source control. Does that help? Well, no, because if we're working in a shared database, we just keep trying to edit the same stored procedure. How do I make sure I don't copy over Grant's changes? Even if we're working on different objects, if we're working in the same database, maybe I've touched 6 different things today. I'm looking at that database and I'm like, what should I bring into source control? It's really easy for me to accidentally bring in Grant's changes and then be like, wait, what happened here? Why do I have this in here? Working in a dedicated database that's associated with my branch helps me. And it can even help me because I may be working in multiple branches at once. I may be like, oh, okay, I'm working in branch X. I've got it. This is going well. And then maybe I have a crazy idea. Maybe it's not so crazy, right? I'm like, oh, this could be cool, but I don't really want to commit the code in this workspace where I've got the stuff I'm really sure of. I want to create a quick new branch for my experiment with a separate clone of the database, be able to make my changes in there, right? And be able to switch back and forth between them. If I'm happy with my experiment, maybe I merge it in, right? But it's very, very useful for me. So being able to synchronize our databases with our source control is really, really useful. And we now have a way that this can be done with cloning and get hooks. And I really think this is very much where things are going as well. This is going to be the new normal for databases, because this is very much the normal for application development and application code. Application developers don't use shared workspaces to develop in, right? They don't share a Visual Studio. They don't all log on to a terminal server and develop on that terminal server. I have seen some organizations where that happened a long time ago. If that's where you are right now, it should change. It should change fast, because that is very much not normal anymore for application development. So what does this look like? Let's take a look at this in action, right? So switching over to my demo here. Oh, and we want SSMS back. So what I'm going to do here is create a new project. I'm in our old friend Microsoft SQL Server Management Studio here, and I've got Redgate's SQL change automation tool here. So I'm going to do a new project. Let's say I've got an existing database. I'm going to start off with a new project, and we're going to give it a great name. We're going to call it YOLO. Actually, let's call it, I use YOLO sometimes. Let's call it Don't Type in a Demo. I'm doing this in honor of Buck Woody, a popular speaker in the Microsoft data platform. He always says don't type in a demo. So I am totally following his advice here. And I'm going to put this in a local folder. We'll call it the Git folder. And it says, it wants to know what is the source of your development. What is the database that you are going to develop in, right? So we could do a new empty database, but if I've got cool cloning technology, what I can do is I can say, I want to create a full copy of the database. So this is a partner session. I'm showing Redgate tooling in this session. Like I said, I really think that what we're going to find is that this is the direction everyone goes in. It will look, if different people are designing this, it's going to look different everywhere, but I'm going to predict that you're going to see similar patterns and capabilities all around you soon. So I'm going to provision a new database using Redgate SQL Clone, and we're going to use one of my favorite databases, the Northwind database. This I'm going to put on my local instance, which is named derp, and we're going to call our dev database Don't Type in a Demo. So I'm going to say OK here, and that creates a lightweight copy of a database. It's similar to a container, but it's just a database that has been virtualized that I can now use for development database. This is based on an image that I created in Clone. Let's take a look at our images over here. We can see in our SQL Clone instance that it says, hey, this is what I just did. Here is our clone instance here. Our image is Northwind, and I have now created this development database. Even if this was a terabyte database, 500 gigs, whatever it is, my clone would be very small because my clone only takes up the space for the amount of data I change. Very similar to something like a database snapshot. If you've used SQL Server's database snapshot, or if you've used SAN cloning or things like that, it takes up the space that writes take up. This is optional, right? I could use a different kind of database, but it's convenient if I have Clone to use a development database. Now here on the Options tab, I could apply filters if I wanted. Maybe there are some parts of this database that should never go to production. I could filter them out. Or maybe they're simply part of someone else's project. Maybe I only work on 1 or 2 schemas. If so, I could use filters for that. I can also edit comparison options, and this includes behavioral things that are really useful. So things like, what if I want to use online indexes? when creating an index, or I can also ignore a lot of things, script a lot of things. So I'm going to take the defaults in this case. And then we come to baseline. So here's the new option we've got on baselining here. This is saying a baseline is, what is the representation of production? And now we can say we want the representation of production to be an image of production, an image which we can update. Maybe we update it automatically every week. Maybe we update it automatically every night. But we are going to use that image, which comes from production, which might have the data automatically already masked and things like that in it, right? We're going to use that as the basis for our development. We can use a script if we want, but we no longer have to use a script. So I'm going to select an image here, and I want to use the image that came from production. In my case, the Microsoft, I love the old Northwind database, so we're going to use that. And I'm going to go ahead and create the project there. When I create the project, what SQL Change Automation does is it sets this up with the clone image as a baseline. And then you'll see it does something here. It updates the offline schema model. What's that? Well, let's take a look at what that is. I'm going to click Done here. And when I go over to my version control tab, well, it tells me, hey, this isn't a Git repository. This is a new project. So I've just, let's restart Visual Studio real fast because I did just apply an update. I need to go ahead and initialize my directory as a Git repo. So we'll do change directory to Git, and then we called it don't type in a demo. I'm just going to run git init there, right? So I'm just initializing this as a Git repo. And now when I go back and I refresh my version control tab, it says, oh, I do see things that you've done in this project. And notice that we've got here things like schema model. Hey, that's the definition of a stored procedure. By default, we can see there are some of these that are tables as well. Here's some views. Oh, there's a table. There are more tables too. By default, it will script out all your objects because, yes, we want, when we're validating our changes, we want to run them against that representation of production. But we do also want to check in all the definitions of all our objects that we have an object history over time, and that we always know what the before and after of a change is. Now let's go ahead and, while we're setting this up, let's also set up that get hooks thing I talked about, where we can have different databases, different lightweight clones for each branch that we're using. So I'm going to go ahead and grab a little code here. We have this code in our documentation, and I'll slide this over so you can see it too. What I'm doing here is I'm going into the Git folder. And if you want to do this in a different way so that you can share these hooks with your team, you totally can. What I'm doing this is I'm putting these hooks into the hooks folder to test them out for myself. You might want to play around with this feature first. This folder won't be checked into source control by default. This is just a local folder for you. So if you want to try these out here, then you don't have to share them with everyone right away. And you can grab the code for this on the Redgate site. I'll get links for this to share with the video. So what I've got is I've got a post-checkout hook. Notice that these say sample on them. Things that say .sample will not run. This one has no extension, which means that Git will see it as a hook and will run it. And if we take a look at this, if we open this with code, we can see that in here, what this is saying is every time I check out a branch, it is going to run a PowerShell script. And what is that PowerShell script? It is the PowerShell script I've also put in the directory. Well, let's take a look at the PowerShell script, clone branch.ps1. If I open this with code, I can see that it has, and you change this for your environment. You tell it, where is my clone server? What is the image I want to use for this project? Where do I want to put my clones? In this case, I don't have an instance name. And then what database do I want, what's the name of my development database? So in our case, this is don't type in a demo. I'll save that there. So this means when I check out a branch, whether I am checking out the branch, and let's go ahead and I just refreshed my database list there. Let's go ahead and in my version control tab, I'm going to do my initial commit. I'm just going to call it initial commit for my project. We'll go ahead and commit there. Now I have the option to change branches. I'm going to go ahead and I'm not going to get too far ahead of myself. I should go ahead and I want to set up my remote branch in Azure DevOps just because I want to show you what this looks like in a pull request workflow. So I'm going to go ahead in I have an existing project here. I'm just going to do a new repo in an existing project. You could be using GitHub. You could be using Bitbucket. You could be using whatever your preference is. I'm using Azure DevOps. I'm going to name this don't type in a demo, and we'll go ahead and create that. Now I want to use my existing repo that I already initialized. So I'm going to go ahead and copy that there, and then back in VS Code, let's close a little windows, do a little housekeeping there. I'm going to paste that code in, which I do need to change to the right directory. It says, by the way, you're not in a Git repo. So I need to actually, let's go to Git, don't type in a demo. I have a couple directories that start with D in there. There we go. So this is a Git repo. We can tell because I have Gitposh. Is that the name of that? I have that. I have a PowerShell commandlet module installed that if I'm using a Git folder, it helps remind me of what branch I'm in. So now I'm going to paste in that to tell it where is the central repo, and then we'll go ahead and push that initial commit up to the central repo. Now I could have done that push in Management Studio, but I went ahead and did it. So if we refresh here, we can see, hey, that's all clear now. All right. So now like this, we've simulated, hey, the project is set up and now we're starting to work on some changes in the project. So let's create a branch, and I'm going to use an Azure DevOps naming convention that I think is really useful, where you can put a / in and it will kind of logically organize these in logical folders. So if you view your branches, it will put all the feature branches in one place. So if you use release branches, it'll help keep them separate. It's a nice thing that Azure DevOps repos do. And we'll call this test feature. And I'll click create here. Now, if I have configured this properly, we go over to SQL clone and notice that it says, hey, I just created a new clone called don't type in a demo. What happened was when I switched to this branch, the get hook went into action because I checked out the new branch and it said, we want to go ahead and create a new clone for you to work in based on the image that is associated with your project. And the way that we do the naming for this is the new one. Whenever I'm working in my current branch, it always has the database name without a branch name in it. I used to be in the master branch, so now I have a database I can switch back to. If I switch back to that, let's go ahead and switch back to it. Let's say I want to go back to that branch. I'm now checking out the existing master branch. And now here's my dev database always has the same name. And now that test feature branch that I was in has that other name. So I can switch back and forth between them if I need to. Let's go. And if I pull down someone else's branch similarly, I've now checked out that branch and I can have a database associated with it. So I'm going to go back to features, test feature now, and it'll do that switcheroo with the naming. And if we look in the clone logs, we can see that it isn't recreating them every time. It is using a rename process for it. So that if we make changes in there, like maybe I change the data around, the schema around, I don't want to have to replay it every time. I don't want to have to remember whatever I did to my test data every time. So let's go ahead and make some changes in here. If you ever forget what is the name of my dev database, by the way, it's right on the generate migration screen. I may have had that problem sometimes. So we're going to modify something. You could use the GUI. You could do it in T-SQL. You could follow your heart. We're going to call this new call. We're going to make it an in-care 10. I just did Control S. So, right, I just saved this using the graphical display. And let's say that we also maybe, create proc dbo.newbie as highbuck. Maybe, I think we need to select, and it's not create proc, it's not create prod, it's create procedure. There we go. So SQL prompt is letting me know that, I'm not doing it there. It helped me out. It helped me do this right. So there. Coding at its finest, right? So now I'm going to generate my migrations. Let's say I do some changes and I test this. I then click a wrong button because I'm so excited about my demo. But I finally click on generate migrations and remember how this is done. I can see that I have 2 changes. I can see the details of them if I want, right? Maybe I don't want both of these. Maybe one of them was a mistake. In this case, I want both of them. So one of these is a modified object. One of them is a new object. I'm going to go ahead and generate migrations for this. And then I'm going to verify them. What's happening on the verify is that I'm doing a local deployment against this shadow database. This shadow database is a clone based on that production image. This is the bit where I have shifted production testing left by saying, I want to test the changes that I've made against a lightweight representation of production. And even if it's a large database, I can go ahead and do this. So now I have I've committed and pushed this change. I just want to show you what this looks like if I'm going to do something like create a pull request in Azure DevOps. Now, Azure DevOps politely tells me, hey, you just updated this code. Let's create a PR. So I'm going to go ahead and create that. And here is what I want to show you about, even though we're using this representation of production, if we have changed an object, because it's tracking the schema of everything for me automatically, I can still see what the before looked like for the table. So I'm using this representation of production to deploy things, but I also still have all the code for the objects committed to my repo. We want to be able to have both of those, and that is part of the magic. Additionally, if we want to put automation into place here so that as part of our pull request workflow, we can do things like be able to say, as part of the pull request workflow, we want to be able to run a build and run a deployment of this to a clone. We can do that as well so that the reviewer of this pull request has a full and rich environment to validate their changes against. And this is where we get to the new normal. Because of what we've seen in terms of the desire for being able to deploy frequently and the level of competition that's really, really ramped up in the world, we're now at a place where the patterns that we've really learned well in application development to be able to develop things quickly and with quality, these are now moving into databases. But in order to do this, we need to be able to do that because databases are so critical. And because it is so important to not mess up the data, we need to have that ability to have a representation of production in our development environments early on. We need to be able to tell, right? Pulling that image of production into the development environment early on also empowers us to see things like, hey, wait, did something change in production that hasn't made it into source control yet, right? Maybe someone had to make a change at 3 a.m. and they forgot to create a pull request afterwards. We need to be able to detect that drift really early in the development lifecycle in order to be able to avoid errors. And that is very much part of why this will be something that's very, very common, I believe, over the next few years. And we're already seeing it becoming quite common. We're also seeing that organizations don't want every team to have a bespoke DevOps process for their databases. And this totally makes sense. Now, this isn't that they don't want people to experiment. Organizations, especially enterprises, in these competitive industries, they want two things. They want to be able to have patterns that teams can very quickly adopt, so they can get started really quickly. But they also want teams to have the ability to experiment safely and to be able to do things like try different things with their pipelines. Now, we also still have to be cautious and careful with databases. So this means, yes, we need to find ways, and there are ways to do this depending on what tooling you're using, what orchestrators you're using. We want people to be able to experiment and do different things, but we need to make sure to use the principles of least permissions and make sure that the things that teams are working with and experimenting with is code that team owns. And if this could have implications for other teams, that automatically gets pulled into the process. And when they make certain changes, it automatically requires review and conversations with those other teams. This is also a way to bring DBAs into this conversation. This is all, to some database administrators, I think this can be really scary. But the truth about changes like this is that it takes away the drudgery of manually creating and overhauling development environments on request with old technology every 3 months or 6 months or a year or whenever you can get around to it. And it opens up your role to be more of a specialist in terms of what are the riskiest parts of this to change, right? What are the parts of the database where if we change this, we really should have a conversation early on? Because that can be automated. Bringing database specialists into the conversation is something that automation enables, not something that it prevents. Learning how to work with these technologies actually can very much make your job more meaningful and make you more relevant and more valued, because you're no longer a person who someone is just waiting on to do a manual task. You're someone who is helping provide insights into how to do development and delivery the best. So learning more on this topic. We have a load of different kinds of content that we have been building on this. We've got some technical articles on how to do the things that I have shown today. And these are not clickable on your screen in the video, but they will be clickable in PDFs of the talk as well as other formats that we'll make sure get to you. There's also useful research. If you're looking into building a business case for this or helping people understand this or to learn more yourself, Redgate does a State of Database DevOps report. The 2021 is out. I helped author that, so I do hope you like it. If you don't like it, please let me know. Also, there is the Accelerate State of DevOps report. This is done, it's now done by Google. Google acquired DORA, the DevOps Research and Assessment Group, late last year. So I think we've got 4 or 5 different State of Database DevOps report. Redgate's been doing that for a few years. And I think there's 7 or 8 Accelerate reports. Start with the latest. It's 2019 for the State of Data, or sorry, it's 2020 for the State of Database DevOps report. The Accelerate report, the 2019, is the most recent one because they release at the very end of the year. Also have some articles here on the right. These are higher level articles that I've written on topics like why we're seeing so much change in financial services and how folks are enabling their patterns, as well as things that we're seeing for people to work with adoption for large teams and working with legacy monolith databases. Thank you so much for joining me for this partner session from Redgate at SQL Bits. We are very, very happy to be a sponsor of SQL Bits, and I am so happy to be with you today. Bye, folks.